This Riverwatch video is to train you how to estimate discharge for your stream. Discharge is the amount of water moving past a certain point for a certain amount of time. It's a very important factor for determining what kind of animals and especially macroinvertebrates you'll find in your stream. The first thing you will do is measure the width of your stream. You'll want to find a spot with uniform flow where all the water is together in one channel. This will help you to measure the amount of water flowing through there a little easier. Make sure there's no islands, gravel bars, or major obstructions in the area where you measure your discharge. First thing we do is measure the width of the stream. This is from kind of the wetted edge of the stream where the water comes up to the bank on one side all the way to where the water comes on the bank on the other side. So Allison is going to go ahead and put a flag down on this wetted edge. Good deal. This is where we'll measure from. You grab your 100-foot tape measure and you walk across to the other side. It looks like we are at 16 feet. So we mark down 16 feet on our data sheet for the width. All our tape measures are in decimal feet. This helps ensure that the math is a little bit easier than if you had to convert all inches and feet together. So it kind of breaks everything down in tenths. The next thing we do is we need the midpoint of the stream. So right in the middle. If we're 16 feet wide, that means we need to mark 8 feet. So what I'm going to do is go to Allison and reel this up to 8 feet. Right there. And then she's going to hand me a flag. We'll pull it tight again, make sure we're 8 feet, and we'll stab that right down the bottom. That is our midpoint of the stream. After that, you don't really need your tape measure for this anymore, so you can reel it up and set that off to the side. The next thing you will need is your dip net. These are not only good for collecting macroinvertebrates, they also are good for measuring depths. They are marked in decimal feet all the way up the handle. From the end of your handle to the frame of the net is 5 feet exactly. So the first thing we'll do is take our depth measurements. As you see on your data sheet, there are 3 lines for you to record depth measurements in feet, and then we will average those 3 together. The places we take them are between your wetted edge on one side and the midpoint. So kind of estimate where the middle between those is. And then what do you have there, Allison?
0.6.
We have 0.6 feet for our first depth measurement. So you would record that on line number 1 for depth measurement. Now Allison is going to measure at the midpoint of the stream using the net handle.
0.4.
0.4 feet, so you'd write that down. And then she's going to measure our last depth measurement. It's between the wetted edge marker and the midpoint. What do you have, Allison?
0.3.
0.3 feet. So we've recorded all of those on our sheet, and then we can average those together later. The next thing we want to do is get ready to take our velocity calculations. Velocity is how fast the water is moving, and we measure it in feet per second. So we are going to mark off a 10-foot lane for us to measure the water speed in. As I said earlier, your net handle is 5 feet long from the end of the handle to where the actual D frame of the net is. So you could lay that down in the stream and mark 5 feet upstream from your midpoint, just like Allison did right there, and then put a flag down. Now you'll want to lay it down the other direction, downstream of your midpoint. And that's your next 5-foot section. So now you are 10 feet from upstream to downstream flag. That is our lane where we will measure the water speed. To measure water speed at Riverwatch, we use practice golf balls. We use these because these are neutrally buoyant. They float just below the surface of the water and are a good indicator of how fast the water is moving. So we will time these, how long they take to travel 10 feet. Now we have 3 lines on our data sheet to mark velocity, so we're going to measure it 3 times. What you want to do is measure it, you want to drop it just upstream of your upstream flag, and then when it gets to the flag, you want to start your timer and see how long it takes it to get all the way down to the bottom, the downstream flag. And that is how much distance it covered and how much time it took to cover 10 feet. And so our 3 lanes where we'll take our velocity readings are where we took our 3 depth measurements. So between the outside and middle flag, at the middle flag, and between the outside and middle flag over here. So those are our 3 lanes where we'll measure velocity. Now, you may encounter some areas of your stream where your wiffle ball hangs up or gets into some weird flow. You may not be able to, it may not make it all the way down. If that's okay, if that happens, you may not get 3 velocity readings. Try to get 2. If you can't get 2, try to get 1, and we'll use that to calculate discharge. If your wiffle ball hangs up, give it a few seconds to make it out and keep going downstream. If after half a minute or so, if it doesn't make it down the stream, go ahead and pick it up and try to take a measurement in one of your other lanes. So we're going to get ready to drop the wiffle ball. Allison is going to stand a little bit further downstream near the flag so she can see when the wiffle ball makes it past the flag. And then I'm going to drop it in the stream, and I'm going to tell her when to start her stopwatch. When it gets past this flag, you can drop it upstream of it just a little bit. You want to make sure you're not standing upstream of the ball you drop in, because your body can obstruct the flow. So you want to stand off to the side. I'm going to drop it in, and then I'm going to tell Allison when to start her stopwatch. We're kind of between the outside and inside flag. Go ahead and start your stopwatch, Allison. Slowly making its way down. This is a slow flowing creek right now. And then when the ball makes it past the flag, Allison is going to stop her cell phone timer. All right, what did you find, Allison?
25.19 seconds.
25.19 seconds. I'll record that. Could you grab that? Thank you. So first line of velocity, 25 point, we'll just go to 1 decimal place. We'll put 25.2 seconds. Thank you. And now we'll measure velocity in our middle lane. This is our next velocity measurement. Remember to stand off to the side, drop it a little upstream of the flag. All right, go. Allison has started her timer. A little bit faster flow right here in the middle of the stream, as you might expect. That's why we take 3 readings so we can average them. All right, the ball has made it past the flag. What do you have?
16.77.
16.8 seconds is our reading. So far so good. We have 2 good velocity readings. Now we're going to take our last one. We'll see if it makes it. We have a little bit of vegetation growing into the stream over here. I'm going to drop it just upstream of the flag. Go. Allison has started her stopwatch. All right, the ball also made it all the way down on this one. So what did you have, Allison?
17.19.
17.2 seconds is our third time. All right, and then in a little while we'll do the math, and we'll divide those times into the 10 feet to get feet per second. And then after we do all that, we do the math. We will multiply our average depth by the stream width by our average velocity, and that will give us the discharge of the stream in cubic feet per second. So the volume of water flowing through the stream at any point in time.